Okay, now let's begin our discussion with alpha amino acid. Again, organic chemistry, pretty much interesting. So now let's start with what exactly do you mean by alpha? Why is it that I've written alpha? Why not one amino acid? Why not two amino acid? Now, most of you might be aware of the fundamental principles, basically. You could say simply basics of organic chemistry. When you have something like a carbonyl group, and then the adjacent carbon is called as alpha, and then you have a beta carbon, then you have a gamma carbon, then you have a delta, so and so on, right? So now this alpha has to be something which is related to it. Now as the name suggests, it has two principal components. You could say functional groups, right? So what exactly do you mean by functional groups? Let's recall. Functional groups, it is nothing but that part of the molecule which is going to decide that what that molecule is going to do. Example is what it is going to decide that what this molecule is going to have, like physical properties and chemical properties, something like that. So now amino, you have NH2 group, that is an amine, right? You also know that this is a primary amine. If you substitute one hydrogen by a methyl group or methyl group, you could say it is primary amine, and then you have something like a secondary and a tertiary amine as well, right? So this is primary amine, this is secondary amine, and then this is tertiary amine. And then you have something when all the four nitrogens are substituted by alkyl groups, you call it as a quaternary ammonium salt, right? So now when you talk about acids, organic acids, so you're talking about carboxylic functional group, right? So now what exactly is alpha amino acids? So alpha amino acids, they are generally, let's talk about representation. So they are generally represented as, now let's draw the structure rather than just putting directly. So you have carboxylic acid group. So I want you to pause this video and try to see that whether you are able to draw an alpha amino acid on its own. Now see here, this is the carbonyl carbon, so that means you have a carbon which is adjacent to, directly attached to it, so you have an alpha carbon. So this alpha has an amine group which is present on it. So this is nothing but the structure of alpha amino acid. So you need to put one hydrogen to make sure that it is balanced, right? So this R, I'm just simply putting this R. This R can be any alkyl group, okay? It can be any aryl group, or it could be even hydrogen. So depending upon this, you have different amino acids. When it is hydrogen, let me write down the structure. It is CH2, NH2, and then you have COOH. The name of this compound is glycine. So we have essential and non-essential amino acids. Among this, glycine is the only amino acid which is achiral. That means it is optically inactive. Okay. So this was about the alpha amino acid general introduction. Now let's concentrate on the principal functional groups which are present in the compound. So the two functional groups are present in the compound are carboxylic acid and amino group. So you know this has a carboxylic acid and it has an amino functional groups. That is amino, I'll write it as NH2 functional group. Okay. So now let's recall the principle of acid from the chapter on ionic equilibrium or acids on bases, which you might have studied previously or just in your school or college levels. So now carboxylic acid, all acids tend to release proton, or you could simply say they are proton donors, right? So if I have to write a carboxylic acid reaction, I could simply write this gives COO minus plus H plus, right? Whereas when you talk about amino, you know amine, it contains nitrogen which has a lone pair, so it is a base, right? So this base, you know, all bases, what exactly is the role of base? So all bases, they donate or they lose electron. Okay, so bases are also, you could simply say, proton acceptors. Okay, now this alpha amino acid has both acidic and basic functional group, so it is going to exhibit some different type of chemistry than if only one functional group is present. So now let's try and understand what are the different aspects. So you have RCH. I'll simply write NH2. I'll then write C double bond O OH. So now what could happen? Now you have an acidic functional group over here, you have a basic functional group over here. So there could be some sort of intramolecular hydrogen transfer. So what could happen here is this hydrogen, acid will donate a hydrogen. So it releases hydrogen. Okay, so this is acid. Then what happens? Base takes it, right? Because bases are generally proton acceptors. So H plus is called as a proton. I hope most of you know about this, right? So now what exactly is going to be the structure? So now let's try and write down the structure. So the structure is going to be something like this. I write R, I write CH, and then instead of NH2, NH2 has received a proton or accepted a proton, so it forms NH3 plus. And then you have C double bond O, and then you have O minus. So if you could see, this ion has positive and negative charge. So you could simply call it as dipolar. Now there is one positive charge, one negative charge. So even when it is charged, it is neutral. So you can simply call it as neutral dipolar ion. This neutral dipolar ion is called as Zwitter ion. Okay, so Zwitter ion can be defined as a neutral dipolar ion which is formed as a result of hydrogen transfer from an acidic functional carboxylic acid to the amino functional group. Okay, so all alpha amino acids normally exist in the form of a Zwitter ion, which is nothing but a bipolar ion. Now, you could say that this is a neutral amino acid. Now, if you could say that if you have a chain of amino acids, there will be a lot of acidic function, a lot of carboxylic acid groups and NH2 group. So depending upon it, we are going to study or learn the classification of alpha amino acids. Okay, so and then we'll be studying the different types of alpha amino acids, some essential and non-essential amino acid, and then we'll be studying the names as well as the different types of acidic amino acids and basic amino acids and neutral amino acids. Okay, now let's understand the behavior of this Zwitter ion. So let's have a review. What exactly is a Zwitter ion? Zwitter ion is neutral bipolar ion, and which is formed by hydrogen transfer from the carboxylic acid functional group of alpha amino acid to the amino group of alpha amino acid. So let me represent a Zwitter ion. So this is the alpha amino acid RCHNH2, and then you have C double bond O OH. Now it forms a Zwitter ion, so you could write it as RCH. So this hydrogen transfers from here to here. So you have RCO NH3 with a positive charge, and then you have C double bond O O minus. Now let me put this reactions in two different media. First is acidic media, and then the next is an alkaline or I could simply say a basic media. Simply I'll write base. So now what are the reactions that can happen? First, in acidic media, what exactly happens? In acidic media, this O minus gets protonated. Okay, and then you get RCH NH3 plus COOH. And if you observe that positive charge has become neutral. Okay, so that means in this case it exists as a cation. So you call it as cationic amino acid, alpha amino acid. Okay, whereas when it is alkaline medium, let's say if you have an alkaline medium, that means it is a base. This base normally reacts with a proton, right? So now you have NH3 over here. So let me rewrite this RCH. You have COO COO minus, and then you have NH, H, and then this is a positive charge. So you have OH minus. This OH minus will hunt for H, right? So it will abstract the proton, as a result of which the electrons will be given to the nitrogen, and then you have something like this, RCH, and then this you have NH2, then you have COO minus. So this exists in the form of anion, so it is called as anionic alpha amino acid. Okay, so it exists in zwitterion would exist in the form of a cation in acidic media and anion in basic media. So this was about the behavior of zwitterion. Now let's say if you have the cationic amino acid, and then if you just put it into a solution, and then you have two electrodes like cathode and anode. So as you might be knowing that cathode is negative and anode is positive, right? So this is a cation. So cation, it migrates to cathode, right, which is negative electrode. Okay, whereas this anion, it migrates to anode, which is positively charged. Okay, so this is nothing but the behavior of zwitterion in presence of an electric field. So now there is something which you are supposed to remember and understand. The concept is called as isoelectric point. What exactly you mean by an isoelectric point? Isoelectric point, now we are basically concerned about the media. So let's say when you consider this H plus, right? So at a particular pH, now you know that when you have more, like when you have cationic alpha amino acid, cationic part will migrate towards cathode, anionic will migrate towards anode. At particular H plus ion concentration, that is indirectly I am talking about the pH, the zwitterion will not migrate. That means it will behave as a completely neutral species. This particular pH is called the isoelectric point. Okay, this is nothing but isoelectric point. So isoelectric point is dependent not only on the H plus ion concentration, but also the different types of, or you could say the number of NH2 groups and number of COOH groups which are present. So now we are going to study a very important aspect, that is classification of alpha amino acids. So now what could be the basic aspect, what could be the basic in classifying an alpha amino acid? So let's start with the classification. So now in the case of classification, let's have a discussion. So first classification is, this classification is based on number of either COOH groups or NH2 group, right? So they are classified into acidic alpha amino acids, they are classified into basic, and they are classified into neutral. So acidic alpha amino acids, they contain more carboxylic acid group and less NH2 groups, right? There could be 2 carboxylic acid groups, there could be 3, and many, right? In the case of basic, as the name suggests, there will be more NH2 groups and less COOH groups as compared to NH2 group. As the name suggests, neutral alpha amino acids, they would contain equal number of carboxylic acid functional groups and NH2 functional groups. Okay, so this was about the classification of alpha amino acids. So now let's make a list of different alpha amino acids. First is glycine, then you have alanine, okay, then you have proline, then you have methyl, then you have phenylalanine, then you have other different alpha amino acids which we will be discussing. Like there are 20 alpha amino acids which are essential. We'll be discussing its name and its structure in due course of the session.